I'd like to share with you climate change, which is a relevant subject for popular conversation. But I also want to talk to you about Dead Sea mud, and mud is a special fascination of mine. And then I'd like to talk to you about Bible chronology. Although I'm not a Bible scholar, I took one course at university on Bible as literature, but I've read the Bible, and I can comment on what my opinion is of how climate change and Dead Sea mud relate to the chronology of the Bible. I'm with the Logos Research Associates, and this is an ongoing research project that's been going on for about 8 years with Logos Research Associates. And I'm getting ready to publish probably late next year, and another field trip or two to Dead Sea, and I can tell you more about that maybe in the question and answer session. I'm also a professor, adjunct professor at Cedarville University, so I love talking about these things at Cedarville as well with the students. So climate change, Dead Sea mud, and Bible chronology. Okay, you see edge of the Dead Sea, and it's a gigantic desert wasteland below sea level. And but you see the mud exposed, especially in gullies. And there I am in the middle of all this mud. And what do I do? Why am I interested in it? Climate change, Dead Sea mud, and chronology. I'll talk, here's the outline of what I have to say today. My preparation was very muddy. I'll tell you about my experience going all the way back to childhood, and a little bit about why I'm interested in mud. I'll tell you about an extraordinary idea. The Dead Sea is a rain gauge proxy for ancient climates. Think of the Dead Sea as a rain gauge. The rain gauge shows you the level of water, and it helps you understand ancient climate. And that's what I think I can see in the mud. And playing by our culture's rules, I got to tell you a little bit about that. Culture has rules, and we need to talk in the language of our culture in certain ways about things. We have culture now tearing down statues and doing some extreme things. And what's our proper place in talking about things? And that requires methodology. My methodology is very important, and how I talk about what I do, that's very important. So I got to play by culture rules. And I've discovered a gully with 30 feet thickness of mud laminae, which shows the ancient lake's water level and the historic earthquakes, the 30 feet thickness of mud lamination. I want to show that to you. It's especially fascinating to me, and maybe some of the enthusiasm I have for mud might spill over to you, but the gully, 30 feet in thickness, right here at the edge of the Dead Sea in Israel. And then laminated mud can be time calibrated by secular history, by archaeology, by pollen, by radiocarbon, and by earthquakes. And that's what I'm doing. I'm calibrating the mud with radiocarbon, with earthquakes, with the pollen record, and even talking about secular history and archaeology. So that's, and the calibration is very important. And then, but I'm here to talk about lake sediment layers corresponding remarkably with Bible chronology. And you notice I put remarkably there. So at the end of the presentation, maybe we want some fireworks display or something like that to celebrate how remarkable the correspondence is. My preparation was very muddy. Let's say it that way. My mother noticed that I had this propensity toward mud, okay, as a kid. And my mom probably wondered, what kind of kid is this? And why is he so interested in mud and that kind of thing? And rocks and fossils and all kinds of crystals and that kind of thing. Why? Who is this kid going to be? And when I became a teenager, my fascination with mud refocused. I started driving in mud. Okay. And then when I went to university, I specialized in mud, specifically the stinking mud of swamps. Okay, they have alligators and crocodiles out there and all kinds of venomous animals. It's not a particularly good place to be, but for some reason I loved exploring swamps and thinking about especially the organic material that's being deposited. In 1975, I submitted an application for an energy-related grant to the National Science Foundation. And I proposed to study a swamp and the origin of coal. And that was during the energy crisis. And the National Science Foundation said, this is a good idea, let's fund it. And so I was a National Science Foundation scholar appointed to do research on mud, swamp mud, of all things. And swamp mud fascinated me. And I was a half-time employee of the university, believe it or not, during the energy crisis, helping solve the energy problem using mud. Okay, had a good angle and good support. And I banked money during my PhD program. Something incredible happened there. Anyway, the mud fascinated me. There you see the Holy Land in the Middle East. And you can see there's Turkey up there. Here's the Dead Sea Jordan Rift running from the Red Sea through the Dead Sea up into Syria and Iran, and then you see in Iraq, and then you see the Tigris-Euphrates Valley in Mesopotamia, the cradle of civilization. You see the Via Maris, that's the roadway from Mesopotamia down to Egypt. And you can see the fertile delta of the Nile River in Egypt. And then there's this area that's very climate related. And of course, the Dead Sea. And there you see the two basins of the Dead Sea, North and South basins, along the fault line and the earthquakes. And of course, what? It's the boundary between two deserts, the Saharan desert and the Arabian desert. Okay, and it's right on the boundary between. And a little bit of the Mediterranean climate is experienced in the mountains in Israel and a little bit over into Jordan. And that's the area of impact that we want to study. And of course, there's the Dead Sea. So it's very important area, crossroads of civilization. And we have what, 4,000 years of history, historical documentation. The rain gauge idea is appropriate. The catchment basin of the Dead Sea, that brown line you see going all around there, that catchment basin is 15,000 square miles. And the rivers in that catchment basin go down to major rivers and streams, and they spill into the Dead Sea. The Dead Sea has no outlet. There's no outlet to the Dead Sea. It is an enclosed basin. And so when it's wet in that drainage area, the 15,000 square mile area, the lake level can be up, and it also can go down. Okay, it's one of the world's most saline large lakes. In that catchment area, it 10 times the salinity of seawater in places now. The light blue area is a former Ice Age lake, Lison, that sits underneath the present deposits of Dead Sea, the Dead Sea mud that I've been studying. So the level of the Dead Sea is a climate proxy. What do you think of that? Climate proxy. In other words, I can get a picture of climate over the last 4,000 years by looking at the Dead Sea sediment, reading the level of the Dead Sea, thinking about the variation in climate, wet and dry, that type of thing. So Dead Sea is a climate proxy. An extraordinary idea. The Dead Sea is a rain gauge proxy for ancient climate. So, you put that rain gauge out in your garden and you can read the rainstorm, the last rainstorm, how much moisture we got, how much rainfall we got. The same thing with Dead Sea mud. You can read the proxy, and you have a proxy for ancient climate. Okay, the interaction between the Mediterranean climate and the Saharo-Arabian desert belt is what's going on there in the Dead Sea. And it's related to the intertropical convergence zone and the jet stream and the track of storms, and which relate to temperature and global climate and that type of thing. And so, and certainly climate does change, and so we need to think about what's going on. You see the basin of the Dead Sea. Notice there's a northern lower basin and there's a southern upper basin. Modern engineering, they pump water into the the higher southern basin of the Dead Sea, and there's salt evaporation ponds there. And they concentrate phosphate for fertilizer. The northern Dead Sea basin has been drawn down lately because of agriculture and using of the water resources upstream on the Jordan River. And so that's what we see, the rain gauge idea. I've been thinking about the rain gauge idea for about 40 years. And in the last 8 years, I've prospected for what I believe is a location that would be the best evidence for that. The rain pattern, customary rain pattern, you see the desert areas to the south and to the east, and then you can see increasing rainfall. Less than 4 inches of rainfall a year in the southern areas. And then Beersheba through the Negev up into the Judean mountains. And Jerusalem has over half a meter, something like 18 or 20 inches of rainfall, certainly a year on the average. And up in Galilee, you have high rainfall. And over in Mount Hermon area, over in the Syrian border with Jordan, that's a very wet area. So the Jordan River and Sea of Galilee are very significant as it relates to the filling of the Dead Sea Basin. And so you get an idea about rainfall, but rainfall is changeable, and that's what I'm interested in reading, climate change. Now, the desert vegetation along with the climate rainfall. The desert vegetation, of course, is down south in the Negev, coming north in Israel, and into the mountains of Moab over in the present country of Jordan, then you get this Mediterranean type of vegetation, especially evergreen and deciduous oaks. And of course, you've got horticulture and in the forest environment, and olive, for example, and other things. So you can see that rainfall leads to the agriculture in the area. And there's quite a variation in rainfall, tenfold rainfall variation through the Holy Land area. Now, I'd like to talk to you about the two basins of the Dead Sea. There's a northern basin of the Dead Sea. North is off to the left, okay? And there's a southern basin. South is off to the right, okay? And I can draw a cross section through the basin, the southern and northern basins of the Dead Sea. And that's what I've done down here. And of course, the basin of the Dead Sea is the deepest lake basin below sea level in the world. And it has one of the most saline lakes of the world, 10 times the salinity of seawater. You can float in the Dead Sea and read a newspaper while you're floating. It's very interesting, and the northern basin is very deep, hundreds of meters of depth of water in the tectonic depression along the Dead Sea Jordan Rift, and present elevation of the Dead Sea is about 430 meters below modern sea level. MBSL, meters below sea level. That's the elevation. Now the elevation goes up and down, but the southern basin is only partly occupied by water. When the water is above 402 meters below modern sea level, then that sill is overtopped and the southern basin can be flooded with water and stay flooded. So 402 meters below sea level is this magic number that allows the southern basin to have ponded water. Now, today, we pump water up into that basin to keep it occupied with evaporator ponds concentrating phosphate fertilizer. But that's what the basin is like. So there's a northern basin that is continuously occupied by lake, but the southern basin is only occasionally occupied as the lake level rises above 402 meters below modern sea level. Okay, beach deposits are evidence of ancient lakeshore. And I'm kind of into beaches and sediment deposits. And you can see as you walk along the shore of the Dead Sea, you can see ancient levels of the Dead Sea, which were much higher. And so the rain gauge was more full of water in the past. And you can see these crusts, slabs of mineral called aragonite that makes these platy slabs that are laminy with detrital mud or clay mud associated with the calcium carbonate aragonite, and that leaves this beach. And when you see the imbricated fragments of platy material, like up here on the upper right, see the imbrication and the diagonal tilting, that is a beach, okay? And I'm cool with understanding beach, okay? And it's easy to spot. You see the pebbles, the sandy and pebbly character, the imbricated fragments that are stacked up like shingles on a roof, that kind of thing. That's what you're looking for when you're looking for an ancient shoreline of a lake. In the year 1900 AD, the Palestinian Exploration Fund marked the shore of the Dead Sea, 390 meters above sea level. At 390 meters above sea level, they marked the rock showing the elevation of the Dead Sea. At 390 meters, that's above 402 meters above sea level. So what does that mean? That water was flooding the southern basin of the Dead Sea in the year 1900 at 390 meters below sea level. That both basins were occupied by lake. Here's something very interesting. Here's an archaeological site that is early Roman, late Hellenistic. So maybe 150 to 200 BC, right in there. There is a marina at the edge of the Dead Sea. And the archaeologists excavated that, and they believe there was a tower overlaying this foundation, and that tower was where you drove your boat in, and you could unload the commodities inside the tower. Okay, and you could spot the tower easily from a distance, and so that helped navigation. It was kind of like a lighthouse and a storage locker all in one. But it marked the edge of the Dead Sea there, again, about 390 meters above sea level. So that is very interesting. And so we can see the evidence of climate change. Now, since 1900, the Dead Sea has been downdrawn by what? Agriculture and using of water in the upstream Jordan River, especially. And agriculture has caused the Dead Sea to be drawn down to its present level, 430 meters below sea level, something like that. And it continues to drop, maybe a half a meter per year. But the present use of agriculture water wasn't the past use, and so the lake level would remain high if we didn't utilize it. Interesting as it relates to climate change, here's the map of the Holy Land in 550 AD. 550 AD, in the city of Madaba, over in Jordan, in the mountains of Moab, that would be over in here on the map. Notice this map. Its east is up. That's the way it is with Bible maps from ancient times. East is up, north is left, south is right, west is down. And this is a map of the Holy Land that was drawn in 550 AD. Now, in the bottom of the church, the floor of Church of St. George, 250,000 mosaic tiles were assembled to make this mosaic floor. You know, modern churches, the board of directors, they have fights about what kind of carpet to have in the main sanctuary. But in 550 AD, the church knew exactly what to do with the floor of the church. Make it a giant teaching map. And everybody who would go to church would see this map, and they would get familiar with Jerusalem, especially the Jordan River going in, their fish going down toward the Dead Sea. There's no fish in the Dead Sea. There's fish leaving the Dead Sea. They don't want to stay there, of course, because of the salinity. And you can see grain ships on the Dead Sea, that kind of thing. And you can see the Nile River Delta down here, and you can see the Mediterranean off on the bottom of the map on the west side. But notice something, in 550 AD, there was no water in the southern basin. Do you see the southern basin of the Dead Sea is dry? And there are sites there, Zora, Zoar, which is the city where Lot fled from the catastrophe of Sodom and Gomorrah. Zoar is right there according to the map. And so there's lots of things to talk about on this map. Huge. There's books written on the bottom of a map. Anyway, I just do that to show you that the lake level was down in 550 AD. And they were very important. It was very important to describe landscape. Now, let me show you my mud canyon. Now, what I do is I've got a 30 feet deep mud gully, and that shows me in cross section the mud at the bottom of the Dead Sea. The elevation of the top of the mud gully is 410 meters below sea level, and there's 10 meters of mud, so that's 420 meters below sea level. So I have a good extensive, deep mud outcrop to study. What I do is I put wires across the gully, and then I lower ropes, and on the ropes I put knots, and I measure every meter depth in the canyon, and every layer has a depth, and that's what I study. And this is a movie, and so I'll take you through the drone movie. Here goes. So we're flying the drone in the canyon. You can see the layers. The one I'm really interested in is right there. See right there? Look at this. Imbricated pebbles of aragonite standing there. What is this? That's a beach. And that's what's underneath it. Brown and dark gray detritus down underneath it. And up above it, you see layers of aragonite and detritus, laminated aragonite and detritus. And so it makes for a whole bunch of things to study. So down about 7 meters down is the beach ridge. Okay, and fascinated by the beach ridge, and I'll tell you the story about that more fully. See if we can make this keep going. Okay, you can see as we fly the drone into the canyon, around the canyon, you can see what it's like. Then we see those slope deposits. As you go up in the canyon, you see shallow water deposits of aragonite and gypsum and detritus, making the laminated aragonite and detritus deposits. And then flying out of the canyon, you can see the Dead Sea. This is at the southwest corner of the Dead Sea at a place called Wadi Zelim. And this is a new gully that formed by drainage in the last 8 or 9 years, and that's why I'm interested in understanding it. So you're looking off there, and you see the mud delta of the Dead Sea at the southwestern corner of the Dead Sea. That's the lower basin of the Dead Sea, so that stays flooded. Now we're going to look down, and we're going to see the mud laminae and the 30 feet deep. Okay, it's cool. I'm going to freeze the movie. Down at the bottom, 30 feet down, 10 meters down, you can see all this laminae down there. Remember that beach ridges down there, and some other things are going on up above. And so it's layered. It's a layered deposit, and that fascinates me. And so that's cool mud. Okay, we can keep flying down. You can see what it looks like as you go down toward the shore of the Dead Sea. Now we're going to turn here and look back up the canyon. Okay. It's a deep canyon and extraordinary exposure. And after 8 years, I've settled on this gully to be my main research site. Okay, as the canyon, as the the camera turns, you can see the road system going down to the canyon, and then you're looking back up the canyon. And there's the drone pilot. You see the drone pilot in the bottom of the canyon? Gives you an idea of what the 30-foot deep canyon looks like with scale. There's the drone pilot, and he's my research assistant, and he's flying the drone. Okay, you kind of get a really good impression of the canyon here, and he's going to drive the drone down into the canyon and show the layers as we go down. Okay, right at the rim, you can you can see the strata, and then dropping down to the layers in the bottom of the gully. It's really cool. Okay, here is a look at the wall of the gully, and you see the excavation. What we do is we put wires across the gully, and we have belay rope for safety. We can go up against the cliff, and we dig steps going up, and then we pull the and dig the mud out and study the layers. Look at the layered deposit, extremely layered, very interesting. And then down there, right there, I'm seeing the beach deposit, right? This layer running right through here. That's the beach. And as I go down to the left, down the gully, the beach, the pebbles go away and the pebbly sand turns into silty sand, which appears to be the offshore part of a beach, what I call a shore face. And so we have virtually a full sequence of sediment, 30 feet in thickness, 10 meters in thickness. And that's what we're studying. We're real happy with the exposure, and we continue to go out there and look at it. And I'll tell you some things that interest me about it, and as it relates to Bible chronology. The mud shows increasing water depth. Pebbly sand is the beach ridge. As you go away from the beach ridge, up or down, it turns sandy. The pebbles go away, and it's a shallow shore face with winded waves. Then as you move up the sequence or away from the beach, the interlaminated aragonite and detritus appears. The white calcium carbonate layers are called aragonite. The brown and dark gray detritus is clay mud, and that interlayered with the aragonite. And that forms this quiet water, shallow water deposit. Then when the lake gets deeper, the dark gray and brown detritus dominate, and the aragonite goes away, and you have the deep, quiet water of the lake. And then as you keep going, you can find black detritus with iron sulfide. And that iron sulfide mineral is very deep anoxic water. And it's a tip-off that you have very deep water. And so what can you do? The mud shows the increasing depth of water. And I've just sketched it here. Okay, on the wall of the gully, you see the strata right here. And you see our excavation and the 10 meters thickness. And then over here, I've drawn the lake level versus depth. Okay, and you can see how I imagine the mud on the left and what I imagine about it. Of course, this is the modern level of the surface, just recent history. And then down below it, you see history stacked up on top of one another, the whole mud sequence. And I can read in the mud sequence the ups and downs of the lake. Okay, and this is my lake level curve that I drew from for the gully, interpreting the strata, mud strata, in terms of water depth. For example, there's a darker layer right in there, and that's this layer here. And that's got the iron sulfide minerals in it, so it's anoxic bottom water, but yet it has on top of it interlayered aragonite detritus on both sides, mostly above it. Down below it, it has some other things. And so it varies. Deep water depth goes up and down, that type of thing. Down here is a deeper more shallow lake. Okay, shallow lake. And then down here, right here, is the beach ridge. And the beach ridge is at what? 410 minus 7, which is what? 417 meters below sea level, modern sea level right there. Look at that. There's the turning point in the beach of the lake. So I got that nailed. I can tell you exactly what that is. That beach ridge is down there at 417 meters below sea level. That was the edge of the lake. And that's the lowest the lake has been in that whole sequence. Down below in the lowest part down here, I found two sandy beds. It makes this W, kind of a sideways W. And that's the other low stand of the lake. And then look at this. Above it is dark gray and brown detritus, which is a high stand or high level of the lake. I went off to an ancient shoreline of the lake at about 370 meters below sea level. And so I think the lake rose rather abruptly and then declined abruptly. So is climate change real? It is real and very apparent as you look at the mud of the lake, because the lake levels go up and down. In some places, 40 or 50 meters of variation in the water level of the lake. And of course, that's reflective of ancient climate, and I can see it as I do it. So do you appreciate how I look at this? I see this, that sediment, and I think this. I think of a lake level curve. Of course, when the lake level is less than 402 meters below sea level, when it's lower than that, of course, there's no lake in the southern basin. And there's lake in both basins when it's above 402. So you can kind of see the coming and going, the filling and evacuation of the southern lake basin. And that's part of this story. So are you interested in that, the lake level curve? I'm interested in it, very interested, and I spent a lot of time thinking about the lake level curve, interpreting the sediment, and looking around, but I feel very confident about this. So what can I do with this sediment? What can I do? I need to calibrate it. Okay, and I need to calibrate that sediment. There's various ways to calibrate it, but I use two things to calibrate it prominently. I use radiocarbon, and radiocarbon is historically verified on archaeological artifacts. And so I believe that radiocarbon works back to about 700 BC. And so I'm able to draw the increasing age with depth line, and that makes a sloping line of about 2 millimeters per year, average rate of sedimentation. There you see the depth. And down there at about 7 or 8 meters down is where the beach ridge is, and it's somewhere around 1000 BC. Do you see what the radiocarbon is suggesting? The beach ridge is about 1000 BC. So anyway, calibrated by radiocarbon. The other thing it's calibrated by is earthquakes. The earthquakes disturb the sediment layers, And the earthquakes create at the sediment water interface a brecciated or deformed boundary. And I'm able to identify a whole sequence of earthquakes from about 800 mid 8th century BC, about 750 BC, up through 200 BC. There apparently is an earthquake, a prominent earthquake at 31 BC. I can pick that very accurately. It's a very potent earthquake. There's also another potent earthquake at 551 AD. And but notice in here, there's an earthquake at 33 AD, plus or minus 5 years. Could that be the earthquake at the cross? I think the calibration of the earthquake sequence argues for that. And so we have an earthquake sequence in the Dead Sea mud, and we have a radiocarbon curve, which calibrates the sediment. So the sediment shows me the lake level with depth. I can take that curve and I can transform it and make a curve, make a calibration out of it. Now, here's an unusual scripture. The Mount of Olives will be split into from east to west, forming a great mountain, Zechariah 14. Half the mountain will move north, half moving south. You will flee by my mountain valley as you fled from the earthquake in the days of Uzziah, king of Judah. I was involved with reading this verse to students in 1977 at San Diego Christian University. And as I read this statement, I said, man, that must have been a big earthquake, because Zechariah remembered it 230 years later. The inhabitants of Jerusalem knew it was a proverbial earthquake after the return from captivity. And I said to somebody when I was lecturing in 77 at San Diego Christian University, how many of you remember anyone telling you about the San Francisco earthquake of 1906? And nobody raised their hand. And we were in California talking about the California San Francisco earthquake of 1906. Nobody could remember that. Imagine that earthquake in the days of King Uzziah, remembered 230 years later. Which earthquake in the days of Uzziah? It's only one earthquake. And so it's a memorable earthquake. I wrote a paper with co-authors and published in International Journal of Geology Review. Amos's earthquake, an extraordinary Middle East seismic event of 750 BC. I wrote about the event. Something happened. It was interesting. I got into a dialogue with the editor of the geophysical journal, International Geology Review. International Geology Review wanted to publish my paper, our paper on earthquakes and Amos's earthquake. I had 35 references to scripture in the paper, 35 references to scripture. And I used the data of scripture as data. I said to the editor, think about the Bible as data supporting the supporting it. And I sketched looking at the puzzle pieces in the box. The deformed wall at Hatzor looks like it was a big earthquake in the mid 8th century BC, stratum 2B. Architecture's strongly deformed. Here's a south-facing wall. Here's the north-shifted blocks at the base of the outer wall of Gezer. A fortification was severely deformed. Look at the way the blocks are shifted northward off the foundation. Only an earthquake could do that, not a battering ram of an army or anything like that. That is legitimate earthquake damage. You see the wall is inclined. The top of the wall fell backwards as the wall deformed. It was a very significant earthquake that took out the wall at Gezer. In other words, big earthquake in the mid 8th century BC. Okay, down at the beach ridge, which radiocarbon and historic artifacts and history say is associated with the famine of late bronze, collapse of civilization. And the pollen record indicates that's 1100 BC. The bottom of the beach ridge is about 150 years later, so about 1250 BC. There's 150 years of beach ridge, and then you see on top of it, here's 60 centimeters, 6/10 of a meter of strata, and right there is the nail, and you're looking at that. What is that? That's the seismite, or the deformed layer from Amos's earthquake in the Dead Sea sediment. The largest earthquake in 4,000 years likely shook the bottom of the lake severely, and you have over 10 centimeters of a disruption deposit. We call it a seismite. And chunks of mud that were in the sand were not homogenized with the sandy bed. And so that's the evidence of Amos's earthquake, 750 BC. There's another earthquake up here, a thinner one, maybe 150 years later. So everything seems to fit right for earthquake chronology, even up to 31 BC earthquake. That's the earthquake during the reign of Herod in the 5th year of Herod's reign. The straightforward Bible chronology, here it is. You know, we know when the temple was built. Solomon's temple, the 4th year of Solomon's reign, he began to build a temple. It's 968 years BC with Tishri year calendar, Tishri calendar. That's a certain kind of calendar they were using off a lunar month. And so 968 is the date for building of Solomon's temple. But according to 1 Kings 6:1, the 480th year after the Exodus is Solomon's 4th year. So the Exodus occurred 480 years later. Solomon begins building the temple. So the temple, before the temple, about 1446 BC is the Exodus from Egypt. You see how the straightforward Bible chronology goes. And then, of course, Jacob entered Egypt, according to Exodus 12, 430 years before the Exodus. So Jacob is living at 1876 BC, and looking at the records in Genesis, especially Genesis 47, Jacob is born in the year 2006 BC. Just straightforward reading of the Masoretic text of the Hebrew Bible. And then Isaac is born about 2066 BC, and Abraham would be born about Isaac is born when Abraham's 100 years old. So Abraham is born at 2166 BC. You see how that works? Just a straightforward chronology. Now let me take my chronology and show it to you, my lake level curve. Here's what I've done. I've taken the lake level curve and I've turned it 90 degrees. Do you see what I've done? The lake level curve is not sitting vertical. I've turned it on its side, and instead of depth, I've made calendar years on the bottom axis. Do you see what I've done there? In other words, I have a timeline showing you the level of the lake over the last 4,000 years. Kind of cool, isn't it? Now, that's what I think is really cool. And I can use that to compare with Bible chronology. For example, we know that Abraham was born 2100 BC, and so he sits in here. See this? I call that Abraham's W. See that W? That's a low stand of the lake, 2 sandy beds with a mud bed in between it. Sorry. And that sandy bed, those 2 sandy beds, indicate low stand of the lake. So imagine Genesis 14 Remember when Lot looks down from the Judean mountains, the mountains of Judah, likely from Mamre, the south part of Hebron area. He's looking down at the southern plain of the Dead Sea, and what does he see? He doesn't see a lake. There is no lake there. What does he see? The whole plain of the Jordan, the Kirkar of the Jordan, is well watered, well irrigated. There was an irrigation system over the flatland of the south basin of the Dead Sea, and it looked like the Garden of Eden. That's what he said. And Lot chose that land, and Abraham knew that whatever land Lot chose, he had all the land promised to him by God, so he took what's left. And of course, Lot chose Sodom and Gomorrah, and he dwelt in the cities of the plain down there by the southern basin of the Dead Sea. What happened later? That's Genesis 14. The basin is occupied. Then what happened is the lake level rose because we see the brown and dark gray detritus without any much in the way of aragonite bed. So that's argument for deep water. I think the level rose to about 370 meters below modern sea level. And so it was a high level of the lake. And so in 1446 BC, the time of the Exodus, plus 40 years, so that'd be 1406 BC, the conquest of the land is occurring. And what is happening? They see, the children of Israel see what? They see the promised land as a land flowing with milk and honey in 1406 BC, the land of milk and honey. It wasn't a land of tumbleweeds and sagebrush. It was a land of milk and honey. And you know the story of Joshua and Caleb spying out the promised land. They bring back the spoils. They bring back grapes, and they bring back honey, and they bring back all the products of the land, and people see what it's like. And it was a luxurious time. That was the high stand of the lake at the time. And of course, they didn't abide by the promise of occupying the land, but the description in Joshua chapter 15, Joshua 15 gives you the southern boundary of the promised land, and the southern basin of the Dead Sea, or the southern bay of the Dead Sea, is the boundary of the region of Judah, the land of Judah. And of course, water was filling that basin because they talk about the bay of the Dead Sea. Then we have the low stand of the lake at about 1100 to 1250 BC. What does that represent? That represents the time of the book of Judges. Remember, in the time of the book of Judges, that the book of Judges opens with a statement: there was famine in the land. And that's severe famine. And it doesn't say what famine. It says it was just a general famine. And the book of Judges is over a couple hundred years in duration. So it was 150 years of famine or dry time, drought. And of course, the book of Ruth is during that time. Now, you know that Ruth is the principal character in the book of Ruth. She marries Boaz, and they have a son, Obed, and Obed has a son, Jesse, and Jesse has a son, David. So Boaz, who married Ruth, is the great-grandfather of David. And so if David's born about 1050 BC, then Boaz and Ruth are back certainly between 1100 BC and 1200 BC. They're in the middle of the drought. And of course, what is the theme of the book of Ruth? It's all in a giant drought. So do you see how Bible chronology fits nicely? And then you see the time of the kings of Israel. The lake level was low but rising, which is a better thing than the lake level declining. At least it's getting to be better climate. And of course, in the Roman period, what? About 1 AD, what? The lake is up. Herod's looking down from his Masada, his fortress, and he sees the southern basin, the Dead Sea, full of water. And Galatians 5, in the fullness of time, Jesus came forth, born of a virgin. And of course, he came at the right time, and God made sure that Galilee is well irrigated, so the farmers and shepherds and the fishermen could appreciate the teachings of Jesus, of course. And then there was drought about 500 BC or 500 AD. Of course, a Madaba map, the sill is exposed, and then what happens? There's a rise in sea level about 700 AD, and that's the Byzantine period, and then it falls precipitously down to about the time of the Crusades, about 1000 AD. During this period is the ascent of the Arabs, the Muslim ascent, and of course the Crusades, and then the reestablishment of the Holy Land by Crusaders, and of course modern period with Palestine being occupied by a higher level lake and more fertile conditions. That's the lake level curve. So I've talked to you about climate change, Dead Sea mud, and Bible chronology. Talked to you about my preparation. It's very muddy. The extraordinary idea is the Dead Sea is a rain gauge proxy for ancient climate. Playing by our culture's rules requires proper methodology. I've got to calibrate it using radiocarbon and earthquakes. I can't calibrate it using Bible history. If I use the picture on the front of the puzzle to assemble it, that would be biased, and culture tells me I've got to use scientific methodology to make my lake level curve. But I did the lake level curve, and it corresponds to calendar years. And a gully with 30 feet thickness of mud shows the ancient lake's water level in historic earthquakes. And the laminated mud is time calibrated. I can calibrate it by secular history, by archaeology, by the pollen record, by radiocarbon, and by earthquakes. And of course, it's consistent or corresponds remarkably with Bible chronology. Here's my conclusion. Dead Sea sediment displays climate change and earthquake sequence, confirming the straightforward chronology of the Bible during the last 4,000 years.